as I said, like you, we are in the midst of a transformation from paper to digital to now fully searchable and eventually fully linked data. And so I kind of like this slide because it talks about that there's a whole spectrum of experiences we have with content. So we want to be all the way on the right side. We want to build, as I said, we want to build the tree. We want to take every person and link them together with all the relevant content about that individual. But we know all the way to the left is information that's sitting in various sources. It's in archives, on paper, or it's in a microfilm that was taken many years ago, or it's, like I said, in Africa, it's in your mind. And so there's a spectrum of services from the original digitization, metadata about the folder or the book, all the way to text searchability, name entity recognition, eventually the tree, and then the family tree. So that's the spectrum. You might be interested only in part of that spectrum. Maybe for you, what you want is the digitization services. That's great. We're happy to help there if we can be helpful to you. And if not, that's fine. We're just good friends. There's no problem here. Or maybe you want that and you want to get full text searchability. We're happy to help there as well. So it's a range of options, and we just want to share what we're doing to see if any of that is of interest to you. So Thomas, you want to come up?
Thanks, Stephen. My name is Thomas McGill. I work with Stephen. I also wanted to mention a couple of my very charming colleagues. Thomas Hangst, who's a local German fellow. He's in not too far from Leipzig. And then my friend Dietmar Cieslau, who's in Frankfurt. When we were discussing our presentation a little bit, I was wondering if I should add some humor or something fun. And Dietmar's suggestion was, well, Thomas, if you want to have something fun, then maybe you shouldn't do the presentation. You should let one of the charming Germans do the presentation. So I thought about it for a minute, and then I decided, well, the problem is when you have to be on camera in front of the microphone, you need to have some small amount of hair left on your head. So I was nominated to do the presentation, so thank you. Thank you, Dietmar, for the suggestion. Right back at you. So thanks, Stephen, for this introduction. There were a couple of concepts here that I think have been around for a very long time, and some that are a little bit newer to the Family Search Organization. I feel like the National Archives here in Hungary, in terms of sophistication on this continuum, we have been shocked that the sophistication of many of these services from the National Archives in Hungary is so far down the road. We rarely meet national institutions that have this much sophistication. So I think as we get started, I just wanted to mention, we're not the only people, like Stephen mentioned, we're not the only people working on some of these problems. We have some tremendous partners that are way down this road as well. I think this is a fantastic photo. I'm actually the son of a camera operator. I remember helping my dad create microfilm back in the early 1980s when I was just a young child. He was a camera operator. That was his, and he loved doing this. My dad is 82 years old, and now he digitizes records and archives. He just loves it. So that's kind of the first step in the old days. Then these microfilms would come back to Salt Lake City in these metal cans, and then we would write descriptions of the metadata on the volumes, and then we would type them into our systems. That was my life when I began working at Family Search in 1998. Seems a little simple compared to today. I think all of that work, as Stephen mentioned, in gathering all of that content, created a massive stockpile of images. You see the 5.1 billion historical images. It's actually larger than that. Every year it gets larger and larger. At the time that this presentation was created, only about 1/5 of those images had ever had any indexing work done. And every year we're falling further and further behind, just because the volume of imaging, the volume of digital transformation, at least of the images, is increasing. But we're not keeping up, or at least we haven't to this point. So you can see, as a percentage, maybe only 20% of our historical projects have been indexed to date. So this is a serious problem for us, one that we take very seriously. So most of my career has been focused on the human volunteer side of the work, but now let's talk a little bit about some of the efforts with the artificial intelligence or machine learning. We've only been able to process about 650 million records so far, but the speed of acceleration is very encouraging, very encouraging. So I don't know if the images are quite visible now. I just wanted to talk about some of the steps, the 5 steps you see here, the classification of the images, a process we call line segmentation, the handwriting and text recognition, and then this one here, we'll talk a little bit more about natural language processing, or name entity recognition, and then creation of the searchable index. So in this first step, we sort of have to teach the machine the native structure of the documents, and once the patterns of the documents are established, I think this is a Portuguese Latin Catholic book. Actually, I think it's Spanish. Is that Spanish or Portuguese? Anyhow. So helping the machine understand the page breaks down the middle, the new record, the introduction of the dates, and then where the names are located, where the relationships. Once you sort of teach the document structure to the machine, then it can repeat that process over and over. We've gotten quite good at Spanish and Portuguese Catholic language, but then we have to start with the next record type and the next record type. Stephen and I were looking last night. I don't know if we're going to show any slides on this today, but we had done some tests with Hungarian civil registers, and our engines were performing beautifully with the Hungarian language, not because the language is simple, I know it's quite complex, but because the structure of the documents has repeatable patterns. And so once you establish those repeatable patterns, the quality goes way up. And sometimes it takes time to teach the engine. So I can talk a little bit more about line segmentation, helping the machine understand what the sections mean, what the data within the different boxes means. Once you've taught the engine which lines that it should not cross, then it starts to perform better as well. So once you've broken this image into pieces and you've taught the engine what's contained in the separate pieces, then accuracy also climbs very quickly. The next step is actually not the hardest step. I think this used to be the hardest step, but the actual recognition of the handwriting. We're getting better and better at that in many, many languages. I would say the form recognition, the line segmentation, the structure, that's been the hardest part because there's so much variability. Of course, with language, one of the challenges with language is the priests or the clerks, they'll change every so often. And of course, language evolves. And so our engine thinks in terms of decades. So if we were working on a Hungarian, Catholic project, the engine would be taught to think in terms of 1710 to 1720, 1720 to 1730, 1730 to 1740. You get the idea. Each decade, there seems to be enough uniqueness in the structure of the documents and how the language is used that we try to tailor the engine to the specific 10-year window of the documents. That really helps us with our performance as well. Again, these are, actually this is, this is Portuguese. Sorry, I thought it was Spanish. So this is just showing the performance of the engine against the language, the handwriting recognition. Okay, so then the natural language processing or name entity recognition. This is also assisted now that because the translation or the interpretation of the words is not so difficult. I think the more expensive part or the more difficult part is teaching the engine what the words mean, right? We can recognize a word, it's just a shape really, but teaching the engine what the different words means and classifying the different words and fielding the words, that's a little bit more, makes more sense. So I don't know if you can see that there are colors here. I don't think the colors come through very well on the projection, but essentially a color is assigned to each type of entity. So maybe I'm looking for names. I think the names are represented in, I believe, the orange color, or is that the green color? The green color is the names. The dates are the blue color. I think the pink color is a date. And so once you establish these entities represented by colors, then the machine can start to think its way through what means what, essentially. And then if you're in the business of creating a database, a genealogy database, then we can extract these specifically for the purpose of genealogy research. Many of you have other purposes for research. I mean, you have all different flavors of researchers that will come to your repositories. Maybe students studying archaeology or demography. It doesn't really matter what the application is to your content. Once the names and entities are recognized, all the different research purposes can be filled once the names and entities are recognized. So this is just another example of the transcribed text over on the right that's been recognized on this Spanish Catholic register with the different data that's being extracted. We have to, of course, understand in a free text structure, you have to understand where one record begins and where it ends. And so you see these boxes that sort of indicate a new record as well. So I think one of the elements that we recognize we need to do, I don't want to spend a lot of time on this, but of course there are anomalies in the data. Artificial intelligence performs in a certain range, and I would say a very good performance might be a 96–97% accuracy range, which is why we feel strongly that we should allow the crowd or the public users of our products to go in and make changes and improvements, because I think the engine might never get us to the 98–99% range unless we have the power of the crowd helping in the process. And so that's something that we're now allowing on the website, just the improvement of the data from the users. So this is an example where I've gone in, I've recognized that a record is incorrect. I push a few buttons, I offer a correction, and then the system indicates that my change, my improvement has been accepted, and then it's republished. Of course, we have opportunities for volunteers to get involved in this. We have some mobile. We have a mobile-friendly solution. We have desktop services as well. But I would say part of the process of creating highly accurate data will always involve more and more ground truth. So if some of you were deep into the concepts of ground truth, but essentially it's just more and more examples to teach the engine what it's missing. So here's an example, Acuna, where in this mobile application, if it gets it right, I can check on the green box. If it needs to make an edit, then I can go in with the little red arrow and I can make a suggestion for what the correct interpretation would be. Same right here, Domingo de la Cruz. It got this right, but I've seen many examples where it's off by a character, and so we just allow the crowd to go in and make these changes. This fellow here that you saw earlier in the presentation, this is our good friend Henry Germain. He's one of our leads up in the UK. He's a wonderful fellow from Jamaica. He actually digitizes not only with a sweater and a shirt. A lot of times I see him in archives with a tie on, which makes me feel terrible because I'm in management and I don't even wear a tie in management. But he's digitizing your records with a tie and a smile, which I will never understand. He's a wonderful guy. But the intent, of course, is that we would go from the magazine with the stacks to one day later having the names and entities recognized and then published on the website. That's the hope. We're not there yet. So I think at this point I'm going to pass the microphone back to Stephen to finish up the rest of the content.
Thanks, Thomas. We're excited to hear about your experiences with artificial intelligence. Many of you are doing exactly the same things. We're all learning this together, and so what are you running into? What are your challenges? How can we learn and share together? As Thomas says, the secret sauce of all this are these large learning models, right? These large amounts of training data that we can use to continue to tune the engine. One of the great things about what we call curation, or the ability to go in and correct, that the crowd is doing, is it's just, it's feeding that data back into the LLM. And it's training the computer to be smarter the next time around. So one advantage that we have is if you have 400,000 volunteers that are constantly feeding you corrections, you're getting much faster and much smarter. We also use, in some languages, we use highly trained vendors that will go through consistently and look for corrections and make those corrections in the data as well. So those are some things we found that make it a little bit better. You got to start with a lot of good training data, and then you need to constantly improve that learning cycle with more and more feedback coming through the learning process. So delighted to share that, some learnings with you on that. So this is the gold standards. It's expensive. There's a lot of processing time, a lot of kind of Amazon cloud services expense when you're churning through billions of documents in that way. The first step that we're starting with right now for most of our collections is just simply a full text search, but with some very high degrees of accuracy. So we've just kind of started that. We had to you can come to Family Search and try it out if you want to. We can share the link to that later on if you want, because again, this is something we could start applying immediately in archives without waiting for maybe the more enhanced relationship-based data. So just a few examples. We've got 5 test projects there today. where it's just, it's a full text transcription of handwritten documents. And we've been doing this forever, right, with print documents, just basic OCR. But I think some of the advances in taking any script of any language and be able to run a full text search against it, we're kind of excited about that, because now we feel like we can run all 5 billion, 6 billion images through that pretty rapidly, and then come back and do the entity extraction and the relationship building out of that document. So again, that might be something. We are partnering with the National Archives in the United States on full text search with about 300 million documents that they have that they just want us to run them through the engine and give them the results back and see how did it do. And so again, if that's of interest to you, happy to give it a try. So another thing, going just quickly, and we're about out of time, so I'll wrap up here. But going back to this document again, so we talked about different aspects along the way. Really the hardest one, even this may seem counterintuitive, but the hardest thing for us has not been digitizing records. It has not been indexing or transcription. It's been actually building the tree. Because up to now, it requires people, and anytime you require people, it's just slow, right? And we have a lot of people that come to our website around the world. But when you're relying on them to come and make all those connections and build the tree, that's why we have 1.6 billion names in that tree. And that sounds like a lot, but not compared to how many people are available to be built into the tree. So where we're really working right now is on using AI to build the trees. And that has been seen as like maybe the hardest part, because now you're talking about research and inferential research where you don't always have all the data. You're making inferences and conclusions based upon information that you have. And the computer is prone to make some errors or leaps of judgment as it does that. So this has been a really interesting bit of development for us. And what we find, though, and this is not surprising, but you can't do that without a lot of data, right? And so for us, what we do is we take a country and we say, when we get to a certain critical mass of coverage, we have birth records and marriage records. We have all the vital records. Are there census type records available that create broader coverage, as well as maybe some family structure? We look at the records of a country and we try to identify, how deep can we go with those records that would help us automatically build a tree. And when we get to a certain level of depth, then all of a sudden the computer can start to kick in and make some pretty good results out of that. And again, there's some variability here. If you're in an area with a ton of migration, for example, not quite as easy with the people coming and going all the time. If you're in historic populations that are a little more settled. So for example, in Mexico, we've had tremendous results in Mexico because there's great records coverage. You have both civil records and Catholic records. You have census records. And it's a fairly stable population from over the last couple hundred years. So we've had some great results in some of those cultures. We have some experiments out there. You can go and take a look at this. I can show you how to go and try it out for yourself. Here was an Argentina one. It's up on our website. It says the computer scanned more than 35 million records to create a family tree. It ended up being about 12 million individual people out of those 35 million documents. And here's what it looks like. So this was, no human touched this at all. This just, it runs through the AI and it put these relationships together. And the thing that's fun about it is you can click on any one of those and see all the source documentation. What are all the records that we used? What decisions did we make? The computer, I'm saying. And linking those together, all the source information. And then, of course, we can make corrections there. And we're just getting kind of started in this space, but we're delighted to share the concepts and try out some of these together. This goes on, it just shows that, how rich this data really can be, that the computer can figure out these relationships with surprisingly high degrees of accuracy. And of course, the feedback loop, as you know, in AI is critical. We need to continue learning and teaching it. So we have people take a look at these and feedback the results on the accuracy cycles. These are some countries right now we feel like we're getting sufficient levels of content to start building those trees. Because we've been working in these countries for a long time. We have a lot of content in each of these countries. And so, again, some of your countries you're working with are on this list. We'd love to partner with you. We'd love to talk to you share our results with you. And again, I hope this, as we come to the end of this family search section, I hope the message that we're trying to share is that, first off, we're a philanthropic organization that only exists to help and to help you. If we're helpful to you, that's great. If we're not helpful to you, that's also fine. We're not trying to sell anything. We don't make any money off of this. We simply exist to try to help. And that's why our technology is open. All the documents, all the records that we produce are available to you. If we were to index or create a tree, of course we share it with you. You have full access to all of that. And then the only thing that we ask is we want to have that data also freely available on our site. That's what we're hoping to do, because that's how we're helping in our mission to help more and more people come and link their families together.